Presentation should be about 5 minutes, 5 minutes for questions.
Yeah.
And I believe the first presenter is Sam, which I probably barely emails that I have open, but
Say it should be good. Nails.
Sorry.
so I have the PowerPoints open. You just have to share the screen.
So, I don't know how many questions there really are going to be, but that's kind of just how you do it, I think.
Yeah. This was from Saturday.
Ah, yes.
Quality entertainment.
Mike, hit the mic.
Yeah. Oh, it's how we're gonna hear you.
Yeah, facts. Grab the little mic.
Right here.
Yep.
We chose. The graphic, I just kind of, I did this yesterday,
graphic?
and I was just like, I
You shared the screen on Zoom, right?
it's a good question,
Oh, I don't-
that's a solid question. You want me to just share the screen?
I
Yeah,
would be
you need to.
better.
Interesting.
I can add you.
Yes. Oh, it worked.
Hey.
You should be able to share it out.
Is that really colorful one?
Yes, it is fantastic.
You'll see mine's colorful. Mine's sort of colorful. I just use like the default,
I just typed
like.
and took screenshots. I don't think Dimitri's gonna be in there.
We will not be attending this.
Okay.
Whatever. I'm just gonna hold this like one of those TikTokers. Okay, so yeah, so my MATLAB concepts presentation. I didn't really know what else to name it. So the first thing in MATLAB that I am presenting on is complex numbers. So MATLAB is able to differentiate between real and complex numbers. And then you can set equations and variables to like be equal to just like a simple variable. So like, for example, here, I just kind of ran through a couple. I said A is equal to 4 plus 7i, B is equal to negative or 2 minus 3i. And then I did A plus B, which answer came out to be 7 plus 4i, A minus B, A squared plus B squared. And it just came out and showed that MATLAB is able to calculate all of these things, which means that if you end up dealing with complex numbers, you can simplify whatever you're trying to do down to just a simple variable rather than having to type it all out in one go. Next was functions. Very similar to complex numbers. You can set whatever the hell the name is for your complex or your equation, and you have to use the trying to think of the word here, inline like command with quotation marks as you're like marketing for whatever your equation is, and then you have to add with a comma whatever your variable is within that equation. And so here I set Jupiter is equal to inline of 2 times x plus x cubed minus 45 with the variable being x. And then just plugged in Jupiter for 3. You're able to do 2 variables within functions as well. So for area, inline was equal to length times width, with length and width both being a variable that you can input numbers for. Figured out what the area of 5 times 6 is. And then you can do even complex functions right here for circle, sine of x plus exponent of y, x and y being the variables. Plugged in 4 and pi for the x and the y respectively, came out with an answer of about 22.4. So definition of an argument. I don't entirely understand. I'm pretty sure what this like concept within MATLAB is having something that kind of has a repeating function. So if you're trying to do something with n number of trials, and so for here, I did a Taylor series of sine. N arguments is what the second line stands for, number of terms equal 4. I kind of watched a tutorial on writing this out without, I kind of understood what they were getting at. Your correction is gonna be trying to remember my Taylor series. But basically everything with on here is your The correction is the Taylor series x to the n over factorial of n being however many trials you have. With your odd, if you have an odd number of trials, it's going to be approximation plus your correction. And if it's even, it's going to be minus your correction. And so then I kind of just input into the Taylor series, x is 0.5 with 5 trials, came out with the approximation. And then at the very end here is your error, which is going to be your sine of x minus approximation. And you can kind of do this with anything that has a repeating. I just had the Taylor series because that was seemed pretty easy from what the guy I was watching did. And then I had graphing basic functions, which was pretty simple. You just have to set whatever a variable. You're starting with your what's the word I'm looking for? Your increments. So it's 0 to 20 and like giving you x for like in increments of 1. And then I set the function of y equals to x squared. Output all of the numbers or the answers for 0 through 20. And then you're able to just simply plot your x and y, and it'll come up as a figure on MATLAB. And then for integration, this one's actually pretty cool. I had a lot of fun doing this one. So the first thing you have to do when integrating in MATLAB is you have to define your variable, which in this case I have both x and t, to use the sims command, which allows MATLAB to treat it as like an actual variable. Previously, when we were dealing with like functions, it was kind of used as like a dummy variable. It's like the only thing within what you defined as. But if you were to just have done like a function of like x squared plus whatever, and then tried to plug it into whatever you defined it as, that with a number, it wouldn't have come out as anything. That's why you had the comma and then defining x as your variable. But what you do with the sims command here is you define x as a variable, and then you can input whatever equation you want to try and integrate or use. So in this case, I don't think I actually showed it, but I think the function I had was like x squared plus like 2x or something like that. And so when I integrated my f of x in terms of x, came out with x squared times x plus 3 all over 3. And then you see it, and that was my f of x. I have a g, which ended up being sine of x plus cosine squared of x. And it's the nice thing about the integrating function is it'll do complex integrations for you. And if you look at the integration of g of x, it came out as kind of hard to read. It's just a bunch of like backslashes and stuff. So if you do like a pretty function, it comes out as being what you potentially see in like an integration calculator online. And then I ended up creating a JSON and did the integral of that, and it came out as a really, really ugly function. And I think ERFI is some like really unique equation that MATLAB is kind of supposed to be able to know if you're dealing with it. I didn't really know what it was, but it was a cool little thing I learned is that it's apparently a complex equation that it's like E or something. But yeah, so that's my concepts. Yes, I gotta have a second. So here's my functions of f integrating. You're able to integrate between like 2 points. So I did 1 and 5, came out with a pretty nice answer of 196 over 3. Did the same thing with g. I don't think I did anything with the JSON function. But for g here, I integrated from -5 to 5, and it gave me like sine of 10 over 2 plus 5. Function double allows it to transfer into a decimal place. So, yeah.
Thank you, Sam. Are there any questions for Sam?
Everyone.
That like fell right out of my pocket.
I have a question, Zach.
Yes.
Right.
Very good.
In comments before your questions, your font is too small. I struggle to see them.
Yeah, and that was kind of the here, let me turn this back on. That was kind of the thing, was when I was taking the screenshots, I was kind of like, this looks really small on my computer. I kind of thought that when it got up on the screen, it would have been bigger. I was gonna say, I can always like send it to you if you want, because I have that presentation saved, and then it's a lot easier to read, like when you're close up on like the screen itself.
Are you gonna send out, like a copy of all of us
I can.
presentations? That would actually be helpful.
Okay, second question, can you import your equations as graph?
You should be able to,
MATLAB?
yeah, and MATLAB, like you mean into like something like PowerPoint or,
You separated them out to like, when you were explaining simple graphs, like
yes,
with variables,
the plot, yes.
with variables.
Yeah.
So what if it's an equation?
If it's in, you mean, so instead of it being like y squared and x, but it
Yeah.
being like x squared plus
Exactly.
whatever,
Something like
whatever.
that.
It would do the same thing, when you were to plot it, if you were like,
Without me like calculating it separately, like I have to really
like,
the answers before plotting, MATLAB would have maybe like just get the answer and plot the graphs for the equations.
like, just like has like, points rather than kind of like a smooth line, is that what you're trying to?
The examples you gave them as x
Yep.
variables, but in case my equations came out as set of
So your x is like, equation instead of
yes,
like.
exactly. So
Um,
and I don't want to go through the rigors of calculating it individually. So can I just
I was gonna say, I think that's where the y function comes in. The y is gonna be your equation, and then your x is gonna be like your, what you're like trying to go between. Does that kind of answer your question? So I guess I don't really,
understand my question?
yeah,
Okay, I wanted to ask. Okay, I'm supposed to, an example, I'm supposed to find, for X value, there are list of, I had to find the integrations for list of values.
so like an,
Impute
y
for
is-
my, yes, impute for my X values, and for my Y values, I need to compute some complex numbers for a set of numbers, but I don't want to do them individually. I want MATLAB to like, I'll run it through MATLAB, it's going to calculate all this for me, all that for me. Do you understand?
I do, I know it's possible. I'm not very experienced with MATLAB, and so I know that it can be done, but I don't know how.
I just want to confirm if it's possible.
It should be able to be done. MATLAB is able to do a lot of like super complex things like that. That doesn't sound like out of the realm of possibility. Right? I know it's possible to do, so.
Okay, let's thank Sam again.
No, keep it on.
Next up
Yeah,
is,
keep that on. Yeah, just be careful with it.
next up is Elsa talking about vectors in MATLAB.
That was a rough one after that.
Well, I was just like hopped out on like all this stuff.
That's rough. Oh, that looks nice.
It's like, oh, my.
How do I?
Bottom right. Yeah, yeah. Yeah. Nice. Don't forget the mic. Your notes.
Is it still on, Sam?
No,
This
it
sounds like
sounds
it.
off. Nope.
Uh-oh, what did you do?
You broke it when you dropped it.
Is it dead?
It might, it was on a
It was
charger,
plugged in.
unless maybe it just wasn't.
Oh, now we've done it.
That's really awkward.
It might have been on the charger, but not like
Yeah,
secured.
especially after the weekend.
Yeah.
Hello, hello.
It's definitely not.
You show up on the, oh,
You have to
barely
you have
show
to
up on there
change
too.
the, just yell
Oh,
into.
Hi, Dimitri.
Hey, what?
Um,
Hello.
Do we have to select a different microphone?
No, because it should come through.
Should be the same.
Oh,
Well, the audience mic is on, so as long as you talk loud enough, it should
work
capture.
on your projector. Just be nervous loudly, you know?
Right,
I'm-
hopefully he'll be able to hear us.
Yulin, I'm sorry, but apparently the mic has died. As-
Can you hear us okay though?
Unless he's not paying attention.
Oh,
Yulin can hear you,
you
yeah.
typed something.
Okay,
Oh, okay.
I have to open it or it won't go away. Okay.
Oh, clearly.
Nick, all right, so my presentation is on vectors and matrices. Apparently I have to click there. So the first is on scalars and scalar products. So scalars are created by simply introducing them to the left-hand side of the equation. So like x equals y equals, and then you can add them together. They're simple variables that can be manipulated within an algebraic equation. Scalar products are the product of scalar vectors x and y of the same dimensions obtained by the transpose of x times y. Scalars are represented only by their magnitude. So like examples of that are mass and speed are both scalars. The diadic product is the product of x times y transpose, and y is the conjugate transpose of y. And it results in a matrix or just an answer if they're only integers. So the Dirac notation of the ket vector of A produces the vector matrix of 1, 0. And the Dirac notation of the ket vector of B produces a matrix 0, 1. And if you put them together into like the bracket vector, which is A transpose times B, it is equal to 0. So the transpose of a matrix is denoted by like A prime or B prime or whatever you assign your variable to be. It switches the rows and columns of the matrix and it flips it over the diagonal. So as you can see, the original matrices are up there and then the transpose of each. And the determinant is when the determinant is denoted by det of your matrix. And when the matrix contains only integers, the result of the determinant is also an integer. So then you can also multiply matrices together, which is again denoted by just A times B. It multiplies the first row by the first column, and then the second row by the first column, and so on until you get through all of the rows times all of the columns. And so I didn't include my original matrices this time, but this was the answer to matrix A times matrix B. Then you can also take the inverse, which is denoted by your matrix to the power of -1 or INV of your matrix. Multiplying the original matrix by its inverse will produce an identity matrix, which has 1s in the diagonal and 0s everywhere else. Oh, and that is all.
You also for your presentation, are there any questions?
Can you reteach me linear algebra?
No, I can't.
So for all of your transposes, are you doing transpose? Are you transposing them or are you doing a complex conjugate transpose for them?
So everything I found
Question.
called it the conjugate transpose. And I felt like it was just the transpose of the matrices, but it might have not been.
So you were doing the complex conjugate transpose the entire time.
Okay.
Is only because you were doing real numbers is the same,
Hmm.
but if there was complex numbers involved, it would change the
Oh,
sign
because
of
then
it.
it changes the signs of them after they get flipped as well.
So if you want to do just transpose, it's period apostrophe.
Oh, okay, yeah. So I remember doing that, but I was getting the same answers when I was doing it with and without the period, so I wasn't sure if it was changing it or not, but
And that's
I
just
do
because
remember
it was
that.
real numbers.
And
yeah.
yes, and Yulin also has a question. How do you do element-wise multiplication?
I'm not sure what that is.
So instead of where you do matrix multiplication, you're multiplying each individual element of the matrix with each other.
I am not sure how to do that. I did not learn about that in linear algebra or in lab doing MATLAB stuff. So I'm not sure about that one. I apologize.
So that's also using the period. So the period makes it element wise.
Okay,
So period star would be element wise multiplication.
okay.
And wait, what? Can you briefly say what element wise multiplication is in?
So instead of the matrix multiplication, which you're probably more familiar with from linear algebra,
Yeah.
element wise multiplication is going to multiply the elements of the matrix.
So
Pump out the
if I bring
matrix.
up, David, if I bring up this, so it's like 1 times 3, 2 times 4, 3 times 9, 4 times 2, and so on.
Yeah,
Just,
Oh, you just multiply each like row, column, position
by
by
its
the other one.
position.
Oh,
Add them all together.
and then you add them all together?
usually not.
Okay, it would
Depends on
just,
how you do it.
okay,
it produces another matrix. Yeah, okay.
okay.
I haven't heard of that, but that's interesting.
Depends on what the matrix is actually physically representing and whether that's useful or not.
Okay.
Any other questions?
Any other questions for Elsa?
Ding, done.
Next up is Fred. I'm just reading the list Dimitri sent me.
Sorry,
Eigenvalue. Okay.
Oh.
Fred is looking at eigenvalue problems in MATLAB.
Oh, nice.
Let's hear it, Fred.
That one,
just a little.
Is this from your?
All right, let me chew on my
down bad
Tootsie Pop.
moment?
Yes.
Sound bad.
I ended up getting it. Like, I ended up getting killed.
Good as you should.
I just felt so-
Are you still alive?
Yeah.
Hold on, I'm coming.
No, it's not. All right.
Wait a minute. Don't, doesn't like the fat or sorry.
Oh, ATO. did.
You like it the most. Fred, I like that background too. You get points from different things, like different.
Thanks. Oh, I didn't even know. All right, that's the whole thing. So, all right, I'm talking about eigenvalues, eigenvectors, and visualizing matrices in MATLAB, because I'm not really totally sure about that one. But so in this equation, we have matrix A is multiplied by one of its eigenvectors x, and the matrix A transforms the eigenvector. It either stretches it or shrinks it by the same scalar factor as n, which would just be like an integer that's like its eigenvalue. I hope that's right. So then if they, change at the same rate, then if we multiply the eigenvalue by the identity and subtract that from A, apparently, if you multiply that by the eigenvector, that will be 0. So let's explore, shall we?
Before you move on,
Yes.
what is V in your equation?
Oh, did I not switch that out? V is supposed to be X. I have to apologize. There are some mistakes, some discrepancies between variables. I kind of rushed through this.
But P and X are the same.
So there are, this should be X. This should be X. Sorry, that's my bad. And then in the future, we have, instead of lowercase n, there is capital N, which I decided to kind of make that switch because instead of getting n eigenvector, we get a matrix of eigenvectors, which I'll show. So if we have this matrix A, I just came up with a random matrix. And we do this command, EIG or EIG A. It will just give you the eigenvalues of this matrix, which is pretty convenient. You don't have to do any linear algebra, which is good because I don't remember how. So it'll just straight up give you all of the eigenvectors of the, or eigenvalues, sorry, of this matrix. And then I found this other command where if you do X and some arbitrary anything, it could be literally anything you want, in brackets equals EIG, it will return the eigenvectors as in like a matrix X, the first one that you put in, and then it'll return those corresponding eigenvalues as the diagonal entries of the second matrix that you put in. So I can't name a lot of examples off the top of my head of why you really need eigenvectors and eigenvalues. I know that you can use them kind of to determine how molecular orbitals are shaped. But that's pretty much it for as far how we can apply it to like real stuff. But here's how to do it like in the program, which is nice, you know? All right, here's another quick, easy example. Oh, wait. No, we're still proving the last example we did. So remember, you know, these equations, we're just popping these values in to prove them that this does what it should. So if we, you know, put A in for here, we pick one of our eigenvalues for n, multiply it by the identity after we define the identity in MATLAB, and then multiply it by one of our eigenvectors. I think it's that one. I think it's the first one. Yes, it is the first one. You get really, really close to zero. Like that's a really small number. And I did this a bunch and I thought that I was doing it wrong, but then I looked at some more videos and they said that they kind of got the same thing. Wasn't exactly zero, but it was close because of like MATLAB's limits. I guess it doesn't go all the way to zero all the time. And then we can see that if we multiply matrix A times the eigenvector, we get the exact same output as multiplying one of our eigenvalues times the eigenvector. Say you had a problem like this, you had to solve, oh, this is the one that I wasn't sure I should put in here. Because I found this example. I don't know that I fully understand it. But it's another, I think, a good, like, easier representation of how you can just get eigenvalues and eigenvectors, like, just from a very simple command. Yeah, but looking at it more, I cannot tell you in detail how it gets the eigenvector, how you get one matrix of eigenvectors and one matrix of eigenvalues from these two matrices, A and B. Yeah, and then I kind of have the same stuff in here. And I have the wrong screenshot on the right side of the screen. I just realized it's the same thing from that last slide. It was supposed to be something else, but same mathematical justification. So then I also wasn't sure exactly what he meant by visualizing matrices. I kind of thought that you could have like some matrix of probability or some matrix of describing like density, like electron density or surface density or whatever it is. And then with just the surface command, you can just do surf, your matrix, and it will visualize it with this cool graphic right here. You know, as we see, it's all zeros here, but then it increases just as it does like in the graphic there. So it kind of gives you a visual representation of how your matrix is shaped.
Whoa.
This is another kind of crazy example that I found. The mesh grid, I kind of messed around with it a lot. It seems to, so with these, it gives you two matrices, X and Y. The X is from 1 to 10 or whatever you would put in there, in increments of 0.5. And then the matrix of Y is just from 1 to 20 in increments of 1. But then it is also, the scaling changes. It doesn't remain a square matrix as you change the numbers. And I couldn't figure out exactly like what that relationship was, but nonetheless, it spits out a matrix. If we have another, we make another matrix that is, or actually that's just a function or something, I don't know. And then we define like the height in this kind of system of equations, I guess, as you know, the sum of sine X and cosine Y, like of those, I guess of the, it's hard to explain. If you just plot this first line, it's like a plane on an angle in this space. It's like a flat grid. And then defining Z as like the height where you take sine of whatever X value you have here and cosine of whatever Y value you have here and add them together, you get this like shape in the surface. So I don't know, and then doing, you know, defining it as a surface X, Y, Z, that's actually what makes it like a surface in that space. View 3 just puts it in 3D view. And that's pretty much the limit of my understanding for this. This was tacked on in red ink, I might add, in one of the emails to my topics. I don't know why exactly you need this operation, the matrix exponential. So it just raises e to the matrix power of a given matrix. Apparently it's important with the evolution operator, but that's all I can really say on that. It's just a really, really simple command. You just define your matrix and then do expm your matrix, and that spits out the matrix exponential of it. But that's it. That's my.
Thank you, Fred. Are there any questions for Fred?
I have questions, sorry.
Yeah. Oh, man. Oh, wait, I'm going the wrong way.
Okay, sorry.
Here.
Yes, here. For the eigenvalue you picked, do you just pick it randomly from the, because when you were trying to explain, you said you picked an eigenvalue
Yeah.
here, so from the matrix. Or from the, I think from the previous charts, from previous.
Yeah, so we get the eigenvalues twice here, like, well, I have like the one command that just gives you the eigenvalues in these.
Yeah, so why,
Yeah.
like, why did you pick the one you picked?
Because so in this equation, I have the eigenvalue here. And this is the eigenvector that corresponds with this here. So this is the eigenvector, and this is its corresponding eigenvalue. That, and then they match up, like, so I could plug this into there or this into there for the eigenvector. But then I would have to change the eigenvalue to this. I should have included another example where I did try it with like all three of these, and they both add up to basically zero, the same result.
Do you have an idea why it doesn't add up to zero very quickly?
Probably because it's like shaped like that, you know, like kind of a,
Well, first and foremost, I would go guess rounding error.
yeah.
You use 4 digits. Matrix. MATLAB
Yeah, that's
goes
all
way
that they
farther
would
than
spit
that.
out, so, yeah,
Like it, you can tell it to show, you can have it show you more.
okay,
It probably is an issue anyway, but just great, just so you know.
all right, good to know.
MATLAB goes to like standard is 16 digits. If I remember, is it 8 digits? I don't off the top of my head remember.
Your name's a lot of.
Can I go back?
Right, 2 minutes for being Ava.
Yeah, let's go besties. Am I actually next?
Yeah.
Next up is Ava, looking at 2D plots of 1D functions versus 3D plots of 2D.
Yeah, another. Yeah. Hey, Ava.
Yeah, Ava.
Be quick.
Say hi to Dimitri.
Hi, Dimitri.
In time, because I put videos in my.
Oh, God.
Oh, Lord.
What?
It's not
You'll
actually in
see.
the Zoom. I just know that you just don't have to watch it recorded.
So much. Aw. Okay, everyone, this is my presentation. I think I'm posed. So first thing I'm gonna talk about, some of these. Oh. Is that supposed to be like black on?
I have no idea what's causing
It's
that.
because.
Yeah, because it's not like centered right.
Oh.
Yeah.
Oh, okay, well,
Yeah.
some of these topics have kind of been touched on, but it's okay, we're just kind of gonna talk about them again. So I have, as, I don't remember who was talking about it, I apologize, but the first, the x equals, that's kind of my range or my increments of x values. I just did a simple sine curve for this. Seems like a pretty standard example that we all can understand and we can expect what it would look like. And so then, since I have my x values defined and my y function defined, you can just say to plot that value. One thing you might notice is my curve is purple and the lines are a little thick, so that's going to be a sneak peek of what I'm going to teach you later on. So get ready for that. So next is our fun spiral that we did in class. So this kind of similarly to my 2D plot of 1D functions, this is a 3D plot of 2D functions. So I have my x values put in there as well, but instead of a 1D function, I have a nice 2D function here. I'm plotting both the real values of z and the imaginary values, which creates this nice 3D spiral that we have. Also, you might be like, what if I want to know the axes titles or something like that? Don't even worry, because I have that information for you as well. So there's a couple different things going on here. This is the same sine curve that I had on the first slide. So I plotted it like normal, but I did a couple things. So where it says plot y and then r line width and 5, what that is doing is the r is for red. So I changed the curve to red, then the line width to 5. So I increased the line width. I think it's usually 1 is standard. Just so it's a bit thicker so you can see it, like for my friends in the background, maybe it's easier to see than if it was a 1-line thickness. So that's pretty easy. I also changed the background to black. K is for black. So you can type in the function for that is set GCA and then the color, because that's what we're changing here, to black. So it could have been blue or whatever other color you wanted, but red and black is a nice contrast colors here. So then to change the plot title, you just do literally type in title and parentheses, and with the sort of singular quote, you can type in whatever you want your plot function to be. So I just did formatting figures because this is my example, but whatever you're plotting, you can just type the title in there. Then to change your X and Y axes titles, it's pretty similar. You just type in either X label or Y label, and then in the parentheses, whatever you want. Since this was just the X and Y axes, I just typed in X and Y. But if you were typing in like speed over time or anything, growth over time or whatever, you can type that in. And this is how you would all do it, just coding directly into MATLAB. There is another way where if you click the little cursor icon, then click on the curve area itself, the blue squares will pop up on the curve and you can click those, and then another page will come up where you can just go in and change the color or the line width and things like that directly. But if you already know immediately, like I'm gonna change the color to red, it's quicker to just type it in that way. So I don't know for sure if this is what Dimitri wanted, but this is sort of my take on it for putting variables into files. So I used the same sign example just for consistency. So I assigned my variables. I put a name for the set of variables. I did ABC here. In lab, we did DDD, I think. So it can sort of be whatever you want it to be. And then here we have the, so we'll kind of what Elsa was talking about with the little, yeah, the little like prime symbol after. That's the complex conjugate transpose, which now I'm kind of don't know if it should be just the transpose or the complex conjugate transpose. I didn't really know there was a difference between those, but this is how we did it in lab. Then you can save it as an ASCII file, that's convenient because then you can open that up in different programs. Like you can open it in Origin, for example, which we use a lot as data analysis. And then I typed in who, that was just defined my variables to make sure that I had everything sort of set up right. And then I typed in ABC, which then you can see this is it sort of in the matrix columns forms. It extends over to the other side. But that's all really one thing. And then PWD is how you can see the pathway with how that file is saved. So mine is saved under my name to documents and then to MATLAB. That's all I have, folks.
We gotta hustle, people.
Give up.
Thank you, everyone.
Next up will be Melody with scripts in MATLAB.
Quick.
Yes. Okay. Oh, right, so I have a couple of different topics here. So the first one we're going to talk about is saving and loading variables.
Oh.
So you can save variables just in case you need to like clear everything off your screen, and then you can load them later on. So in this example here, I'm sorry the text is a little small. But I've just defined a few variables. And oh, I should mention, so this side of the screen is way one, which is by creating a script and like basically pressing buttons. So this is when you open up this editor screen, you type out your variables, and then you can save it with this little button here. And then you can load it into the command window. So this way it saves it as a MATLAB code file, which is different from a MATLAB data file, which I learned. So in these two different methods, you have to pick one or the other. Like you can't try and use this method to load MATLAB code because it doesn't work. But if you open up this code file, you can just press run, and then it'll load in all of your variables. So you can see I pressed who here, and there's no variables, and then I click run, it loads this file, and then now my variables are here. So in this way, you have to type out all of the commands individually. So you have to load in all of your variables, and then you have to type in the save command and define your variables. And this way is helpful because you can specifically designate variables if you don't want to save all of them. So if you don't include any extra text in the command, it'll just save everything. But if you do a comma and then you type in which variables you want, it'll save just those and none of the other variables. So you can see I typed clear and then I loaded this all variables, and it shows that all the variables I typed up here are there. And then I cleared it again, and then I loaded in the file with just a couple of the variables. And then here it shows up with just those two that I wanted. So next is conditional statements. So you can create programs in MATLAB to make comparisons or run tests. And basically you have to follow this setup. So you create for this variable that I want, x equals this matrices or something. If this statement is true, then you have this. And then you can also include these else if and else statements for other conditions as well. And then to close off the conditional program, you have to click end. And you have to have an end for each like for if that's in the program. Okay, so the next thing is animations. So there are a couple of different ways to do animations in MATLAB. The first example I have here is when you make updates to a figure and you show it in real time. So for this example, I defined the function, and then this line just plots what the surface is. This command keeps all the scaling consistent and within the range of what your data is. This one keeps the axes in the figure. This one, I think it's kind of funny that it's replaced children. I don't know why it's that, but basically this one just gets rid of all of the plots that were in there before you add on new ones. And then this command says how many frames you want in your animation. The next one creates the figure and gives it some color. The next one creates each individual frame. So like for frame 1, it's gonna have this many dips and peaks here. And then this is just defining what your variable is, plotting it. The draw now command shows updates to what your figure is. And then the F command captures what it is. So this is basically recording the movie right here. But of course, you're closing the conditional command here. And then these two commands are what play the movie. So this whole section here, line 9 through 16, is recording your movie, and then 18 and 19 are playing it. So this is the movie that I created with this command. Let's see if it works.
That's sick.
Yeah.
That's so
Okay.
cool.
So there's another way, which is, in my opinion, a little bit easier. This is where you create a video file. And so basically you just start off with, you define your variable, and then you open up a video data file. So everything after this open video object file is creating your picture. So yeah, this creates the file, this opens the file here. And then this is defining what your animation is. So you have your variables, and then whatever you want your picture to be. The pause command with the number says you need to wait this amount of time before continuing on to the next frame. And then this one is to get all the frames that are in your animation, and then this writes it to the video file. So then you close the conditional command, and then you close the video file, and then you copy all this into your command window, press enter, and you get a little movie. So this is the movie that is made. So that's it. That's all I have.
Any questions for Melody?
No,
Late to the PQ.
Melody, you have to end the class.
Okay,
Meeting over.
meeting is done.
And with that, the class. That's over.
Got everyone.
Proud of you.
That was the fastest presentation I've given in my entire life.
That was good though, like quality information.
Maria's back today.
Maria is back today.
I'm gonna go sit in the back of the classroom.
Over here. Oh.